All right, we know the chain rule, and so now we can return to the exponential function and say, okay, well, if we have a to the x, and then we can also write a to the x as e to the ln of a, right? Because e and ln are inverses. We could write this then as e to the x times ln of a, right? And so then now in this form, I can say that the derivative of a to the x, if I look at, the very outside, so this and this, I can say that this side would be, okay, there I'd have a e and then an ln or x ln m a. So then I could do this as e to the x ln of a. I should do that in red just to be consistent. So e to the x ln of a, right? Derivative of e to the x is e to the x, and then I would need to multiply that times the derivative of the exponent, which is ln of a. And this whole thing here, if I think about that, that is exactly what we had above here, and so this is the same as a to the x. Okay, so that's where I can say that the derivative of a to the x is the same as a to the x ln of a. So I need the chain rule to formally explain why the derivative of a general exponential function is what it is. All right, let's do our chain rule practice problems. Okay, here we go. Derivative of y. Okay, so I have the 2, and then in the exponent I have sine, and then inside sine I have I have a 3-stage chain. Okay, so I have to take the derivative of 2, leaving the inside alone. So it'd be 2 sine of pi x and then times ln of 2. That's our general exponential function. And then next I need to multiply by the derivative of sine, which is just cosine, leave the inside alone. And then finally multiply by the derivative inside of the sine, which is just pi. Wasn't that fun? Okay. The next one. That looks a little interesting. I'm going to have you try it on your own in just a minute, but before I do that, I want to point out, okay, first, yep, we could instead write this all as an exponent of 1/2, and we can't distribute because of the subtraction, right? And then the other thing I want to point out is that there's multiplication in there, so we have pretty much all the rules we've ever learned all in one problem. Try it out, resume the video when you're ready to see the solution. And there you go. It took me quite a while to get that all on there. Okay. Oop, I gotta close the parentheses here. So I want you to double check my answer with your answer, but I did low and then d highs, and then with the high, right, you have the product rule. So 1d2 plus 2d1 minus high d low chain rule, right? 1/2, and then rewrite the inside, and then when I get in there, inside there, I'd get 2 for the derivative of the first part, derivative of the second part. It's a 3-stage chain again, so bring the 2 down, derivatives, and then rewrite sine, derivative of sine is cosine, multiply by the derivative of the inside. Oof, there we go. And then finally, here we go. Last example. Okay, f and g are functions that are shown. Okay, and we need to find each if it exists. Okay, so derivative of u. Okay, so this would be, let's see, I'd have to do derivative of f and then leave the inside alone. I'll evaluate x in a moment, and then times the derivative of g, and then I just need to evaluate all this at 1. Evaluate it at 1, yeah? So this would be f prime of g of 1 times g, that should be g prime of 1, okay? Now, how do I use this graph? Okay, g of 1 is right there at 0, okay? And so I'd have f prime of 0, yeah? F prime of 0 would be the slope at 0. And I am looking in the completely wrong place. G of 1 is right here, okay? That has a y value of 3. So then I have to figure out what f prime of 3 is. Let's see, 1, 2, 3, here we go. And so the derivative at 3, let's see, that has a slope of 1/4 negative. Okay, and then finally for this one, what's the derivative of g at 1? So g here has a slope of -3. And so here I get a total final answer of 3/4. Okay. Let's do one more together. V. V would be, okay, G prime of f of x, right? So derivative outside, leaving the inside alone, times the derivative of the inside, evaluated at x is equal to 1. Okay, so let's see, f of 1. Okay, 1, here we go, I'm at 2. And then g prime at 2 is here, right? It's a sharp point. The derivative does not exist. And then I could go further, but I can just say overall that this does not exist. Okay, remember, derivatives fail to exist at sharp points. W, try W on your own. Here's my answer. Okay. G of 1 is 3, right? Go to 3 on G, and there the slope is up 2 over 3. So that's where I get the 2/3, and then G prime 1 was, so the derivative at 1 is -3. Okay, so that's going to conclude our examples with the chain rule. Okay, and then we have one more video to talk about parametric curves and tangent lines.